Hello everyone. Today we are dealing with the next kind of appliance, that is the application of the Bernoulli's principle, that is a pitot tube. So pitot tube is a device which will work on the same Bernoulli's principle. So let us see the problems based on that. A pitot static tube placed in a center of 300 mm pipeline has one orifice pointing upstream and other perpendicular to it. The mean velocity in the pipe is 0.8 of the central velocity. Find the discharge through the pipe if the pressure difference between the two orifices is 60 millimeter of water. Take coefficient of pitot tube as CV is equals to 0.98. So it is a pipe like this. In this pipe, pitot tube is placed like this. So here we have the one orifice, that is the hole. Here we have the one more. So here it is open and it is perpendicular to the first one. Okay, so this much they have given. This is water is flowing from here to here. One is at upstream side orifice and other is perpendicular to that. This is the diagram of this orifice. Let us write the given data. So pitot tube, static pitot tube is placed in the center of the pipe. So pipe diameter is D. I'll write it as 300 mm. But I need to convert it into meter, so I am divided by 1000, so I am getting it as 0.3 meter. And difference of pressure head is 60 mm of water. They only had given, so I am converting it into meter. 60 divided by 1000, so I am getting it as 0.06. So 60 divided by 1000, 0.06 meter of water. CV is 0.98. Mean velocity, because the side as well as the center, it is having the difference in velocity. So mean velocity of the pipe is 0.8 times the central velocity. So central velocity will be higher at the sides or the corner of the pipe. There will be the reduction in the velocity because of the resistance. That's what they are taking the central velocity, and mean of that is 0.8 times the central velocity. That is the relation they have given. Okay, so to calculate the discharge, they are asking about the calculate the discharge, right? Discharge, I have to calculate velocity. So area into velocity will be the formula. But when it comes to the calculation of velocity, we have the equation V is equals to that is the central velocity. V is equals to CV into root of 2gh. CV is 0.98, 2g is 9.81, h is 0.06. So we will get with that mean velocity as 1.063 meter per second. But mean velocity will not be same as the central velocity. So for that, what I do is mean velocity, I will calculate it as 0.8 into 1.06. This is what we are calculating. This is the central velocity. Okay, so central velocity is given by 1.063, but 0.8 times the central velocity will be the mean velocity. So 0.8 into 1.06, I am getting it as 0.8504 meter per second, as it is a velocity. But actually what I have to do is I have to calculate discharge, right? Area into velocity is the formula. So area pi d square by 4, velocity is mean velocity I have to take. So d is 0.3 square, so 0.3 pi d square by 4 into 0.8504. From this we are getting the discharge as 0.06 meter cube per second. Okay, so this is little simple, but you have to understand the concept, such as we are calculating the velocity, central velocity, or the place where the pitot tube is placed. From that velocity we are going to calculate the discharge using the formula Q is equals to area into velocity. Okay, so this is how we do the calculation for this pitot tube. Okay, so let us see the next kind of problem. Find the velocity of flow of an oil through a pipe when the difference of mercury level in a differential U-tube manometer connected to the two tappings of the pitot tube, so it is connected to the two ends of the pitot tube, is 100 mm. Take coefficient of pitot tube as 0.98, specific gravity of the oil as 0.8. Here what happened is the manometric reading is given, so I am noting it as x, so which is 100 mm, so which is equals to 0.1 meter. I have to write in meters, so I am getting it as 0.1 meter. And specific gravity of the oil flowing in the pipe was 0.8 they have given, and the specific gravity of the mercury, they have said the differential U-tube manometer is having the mercury, difference of mercury level, they said no, so that means it is filled with mercury, so CV is 0.98. Actually we have the formula. What they asked, they are asking us to calculate velocity, so to calculate velocity I have the formula CV into root of 2gh. This h I have to calculate. No, to calculate h they have given the manometric reading. Similarly, the manometric has having higher density fluid, that is high specific gravity fluid, so this formula I have to use, so x into 13.6, so that is sh divided by s naught minus 1, so 0x is 0.1 into 13.6 divided by 0.8 minus 1, so we will get 1.6 meter of oil. Remember, this is meter of oil, and substitute in the equation, velocity of flow is equal to CV into root of 2gh. CV is 0.98, 2g is 9.81, h is 1.6, so we are getting CV is equals to 5.49. so here they have given the manometric reading, from that we will get the h value. After calculating h value, we are going to calculate velocity using the formula CV into root of 2gh. Okay, so this is also a easy one. This will be asked for 4 marks or 5 marks in the exam, or sometimes they used to ask it for 6 marks also. Let us see this. A pitot static tube is used to measure the velocity of water in a pipe. The stagnation pressure head is 6 meter. So stagnation pressure head is 6 meter. Static pressure head is 5 meter. Calculate the velocity of flow assuming coefficient of tube is equals to 0.98. I will tell you what is this stagnation pressure and static pressure. So U-tube manometer will be connected like this, right? So sorry, it's not U-tube manometer, it's just the pitot tube. It will be having reading like this. Here to here what will come, this is what we call the static pressure. Here to here what will come, this is what we call stagnation pressure. This stagnation pressure and static pressure, some difference, we will get it as the difference in head. Okay, that is 6 minus 5, we are getting it as 1. So V is equals to CV into root of 2gh. So h is 1 and CV is 0.98, g is 9.81. So we are getting it as 4.34 meter per second. Why I have used this taken this problem is because you have to understood the term static pressure head and stagnation pressure head, so that you have to understand. So it is easy for you to know about this. If you want to clearly, I want to explain once more, because that stagnation and static pressure head you should understand clearly. Okay, so till here what will come, it will be the static pressure head. So upon the fluid flow what will happen, it will be rises. So this what we call the stagnation pressure head. Okay, so this difference I need to have, that is what our h, so we are getting it as 1 meter, 6 minus 5. I hope this is understood to you. And next, this is one more little application basis problem based on pitot tube only. A submarine moves horizontally in a sea and has its axis 15 meter below the surface of water. So this is the free surface of the water, and submarine is here. The submarine is here. Okay, so from here to here This axis distance is 15 meter. A pitot tube properly placed just in front of the submarine and along its axis is connected to the two limbs of the U-tube containing mercury. So U-tube containing mercury, for that this pitot tube is connected. The difference of mercury level found to be 170 mm. So 170 mm of Hg. Find the speed. So V has to be calculated of the submarine, knowing that specific gravity of the mercury is 13.6 and sea water is 1.026 with respect of the fresh water. So here what they have given, the manometric reading is given, that is X value, specific gravity of the mercury, specific gravity of the sea water is given. Okay, so only this much is required for us to know H. Once we got the H, then we have to calculate the velocity, which is equals to Cv into root of 2gh. But they have said they didn't say anything about the Cv, so neglect Cv over here or take it as 1. So from that you can calculate the velocity of the submarine. So for that what I do is I have to calculate H first. X into SH divided by S0 minus 1. SH is 13.6, S0 is 1.026 minus 1 and X value is 170 mm, which is 0.17 meter. So we will get H value is equal to 2.0834 meter and V is equals to root of 2gh. 2 is G is 9.81 and H is 2.083. So we will get this as 6.393 meter per second. This is velocity. Actually velocity we used to say in kmph, that is kilometer per hour. Convert this meter per second into kmph. So it is per second it is there. I need to convert it into per hour and it is in meter. I need to convert it into kilometer. Then I am multiplying by 60 into 60 dividing by 1000. From that we will get 23.01 kmph, kilometer per hour. This is what the speed of the submarine. Okay, so this is regarding the submarine. And let us see the one more. A pitot tube is inserted in a pipe of 300 mm diameter. Static pressure in a pipe is 100 mm of mercury, vacuum. The stagnation pressure at center of pipe recorded by the pitot tube is 0.981 Newton per centimeter square. Calculate the rate of flow of water through the pipe if the mean velocity of flow is 0.85 times the central velocity. Take Cv is equal to 0.98. So here the pipe is inserted into a pitot tube is inserted into a pipe of diameter 300 mm. So write everything in the meters. I am converting it into meter as 0.3 meter, and similarly area of the pipe I can calculate as pi d square by 4. So this is the value, and they have given static pressure head 100 mm of mercury, that is vacuum. So minus 100 mm I have to convert it into meter, and that mercury is there, that meter of water I have to do, so I am multiplying by 13.6. So we will get it as minus 1.36 meter of water. So this is what the static pressure head. Then they have given the stagnation pressure head as 0.981 Newton per centimeter square. I need to convert it into Newton per meter square, so I am doing multiply by 10 to the power 4 Newton per meter square. Actually I need to have in terms of meter of water, right? So I need to calculate pressure head. So pressure head is given by P by rho g. So P is 0.981 10 to the power 4, rho is 1000, g is 9.81. So we are getting the answer as 1. Okay, so pressure head difference is stagnation pressure minus static pressure head. Stagnation pressure is 1 minus static pressure head is minus 1.36. So 1 plus, because minus into minus will become plus 1.36, so 2.36 meter of water. This is H value. Now we got H value. Then it is simple, calculate the central velocity first. Central velocity is given by Cv into root of 2gh. So Cv is 0.98 and 2, G is 9.81, H is 2.36. So from this calculation we will get it as 6.668 meter per second. So central velocity is 6.668 meter per second, but mean velocity is 0.85 times the central velocity. So 0.85 into 6.668 will be the mean velocity. So mean velocity we got it as 5.667 meter per second. This is what the mean velocity. So discharge is given by area into velocity. Q is equals to A into V, but V is mean velocity we have to take. So area is 0.07068, V is 5.668. So we will get the discharge as 0.4 meter cube per second, or it will be 400.6 liter per second. Okay, so this is what the discharge calculation using pitot tube. So same pitot tube will be used to find the discharge also. Here the concept is changed. We will calculate the central velocity or velocity. From the velocity we are going to calculate discharge. Q is equals to A into V. Okay, so this is what we have the problems on pitot tube.